So now let's take a look at problem 1. Problem 1 here, there is a cupcake company who makes and sells cupcakes. And we know there is a relation between the price of the cupcakes and the supply of the cupcakes. And also the price is also affecting the demand. So what it says here is that if you change the price, the supply and the demand are going to change accordingly. So we're going to find out the relations by using linear equations. Assuming that the relation is linear, we will need to find out the equation of these two lines. And from our previous tutorial, we know that to determine the equation of the line, we will need to determine the slope as well as the y-intercept. And we can also use the something called the point slope form. So now let's get into it. Basically, we need 2 points to determine a line, right? So we have 2 lines here. So for each of these lines, we need 2 points. So let's see how can we find these 2 points to work it out. The first thing we notice here is that this information, the supply will be 200 cupcakes at this particular price point, $2. So if the price is $2, there are going to be 200 cupcakes for the supply, right? Now, if we take a look at the coordinates here, the p-axis and the q-axis here. The p-axis here, it's the price axis, so it's like the y-axis, and the q-axis here is just like the x-axis, right? So to determine this point here, we know that the quantity will be in the first coordinate and the price is in the second coordinate, right? So that the first point that we found here is quantity go first, 200, and now the y-coordinate or the p-coordinate, 2. Okay, so that is the first point that we have here for the supply line. Now let's take a look at the demand line here. The second, information here tells you if the price is $8, then the demand is gonna be 100 cupcakes, right? So it's a point on another line. We will say the green line here. So another point, 108, right? So notice that we're talking about 2 different lines here. So we can use these 2 points, the purple point and the green point, in a single line, right? Because they're separate. So what we do is we need to find more points to determine these 2 lines separately, right? So now let's take a look at a question A. If the equilibrium point is 600 cupcakes at the price of $6. So this is a very important information that we have to notice here. What does that mean by equilibrium? Equilibrium means the demand is gonna equal to the supply, right? So it could be either the quantity of the supply and the quantity of the demand, right? So if the quantity is 600 cupcakes, then there will be this amount of demand, which is equal to this amount of supply, exactly at this price range, at this price point. So it says if the price is $6, there will be as much demand as the supply. So this point here can be used either for the supply line or the demand line. So it's in other words, it lies on the intersection of the supply line and the demand line. So we have this blue point here, 606, which can be used both for the green line and the purple line. Now let's determine the purple line by using these 2 points. So let's set the purple line to be our line 1, right? So for the line 1, we would need to determine the slope first, which is denoted by m1. So m1 is equal to y1 minus y2 over x1 minus x2. And now which one is our x1, y1, which one is our x2, y2? I will say this is my x1, y1, and this is my x2, y2, and this is my x3, y3, which I'm going to use later. So now let's just plug in this y1 minus y2. That is 6, okay, minus that 6 minus 2 over this 600 minus 200, which is 1 over 100, right? And now I can write out the equation of this line. So I'm gonna use the point slope form, which is y minus y1 equal to m1 x minus x1. This is my L1 here. So this is the point slope form. But in this particular question, the coordinates are actually p and q. So instead of using the variables x and y, I'm gonna rename the variable, which will suit the needs of this question. So instead of writing y minus y1 here, I'm gonna change it to p minus p1 equal to m1 q minus q1. And I'm also gonna change the name of the x1, y1 here. So that is q2, p2. This is q1, p1, and this is q3, p3. Now I can plug in, right? And for this line 1 here, I'm talking about the supply function. So this is p sub s, stands for the supply. So I have now p of s minus p1, which is my 6 here. That is equal to m1 1 over 100, right? Times bracket q minus q1. q1 is my 600, right? So this is the equation of the demand function, the demand line. Okay. And since this question does not ask us to express this equation in the slope-intercept form, so this point-slope form is also accepted. We can just leave it like that. That is our demand function. A supply function. Now let's work on our supply function. The demand function right now. So that's gonna be our L2. But before finding the L2, let's find the M2 first. That is the slope, right? So the slope is gonna be, now I will use the green point and the blue point. So that is gonna be, you can say y1 minus y3 divided by x1 minus x3, or you can use p or q, it does not matter. So I have 6 minus 8 divided by 600 minus 100, right? That is equal to 2 over negative 2 over 500, which is equal to negative 1 over 250. That's going to be the slope of the green line, our demand line. And now L2 can be found by using the point slope form, right? Y minus Y1 equal to M2 x minus x1. Because, you know, the x1, y1 is the point of the intersection, which can be used either for the demand line and the green line and the supply line. But since the coordinates has the name P and Q, so we're gonna change it. Okay, so instead of writing this xy, I'm gonna write P of D, right, demand, minus this P1 equal to M2 Q minus Q1. And now I can substitute the point into this line. My P1 is 6 and M2 is negative 1 over 250. And Q here, Q1, it's 600, right? So now I have my L2, the green line, the demand line, worked out here. So that is question A. How can we find the demand line and the supply line by using the equilibrium point, as well as the 2 points found in the question. And now let's take a look at question B. Draw these 2 lines on the axis below. Label each function and any points of intersection. Okay, so since we have just said that the equilibrium equilibrium is gonna be on both lines, so I'm gonna locate this line first, this point first, 606, which is here, right? This guy here, 606, and my the purple point 202. 202 is gonna be here, right? And also the green point, that is 108. Okay. Now I connect them. The green line. Okay. And also the purple line. Purple line here is my supply function, and this green line is my demand function. Oh, sorry, PSQ, PD, not PS. So this is P D of Q. Okay. So that is the answer of question A and question B. Now let's take a look at problem 2. Problem 2, we have this kind of swimming club, and membership is available for sale, right? And also we're gonna find out the price of the membership, and the weeks after the starting of the summer, when we join the club. So basically, what it says here is the price is gonna change, right, according to the time the timeline that you join the club. So the later you join the club, the cheaper the price is. Okay. So we're gonna find out 2 points, which will determine the equation of the line of this function here, like the question before. So firstly, the first condition that we have here is the swimming club costs $150 for 12-week summer season, right? So if you join the club right at the beginning of summer, you're gonna pay the full price, $150. So notice that I said right at the beginning of summer, that is mathematically 0 weeks after the beginning, right? So it's right at the beginning, 0 weeks after the beginning you join the club, okay? And our x coordinate is gonna be the number of weeks, as is indicated in the question here, right? A function, right? Phi function as a number of weeks that has elapsed when the membership is purchased. So the x coordinate is gonna be the weeks after the beginning you join the club. So it's gonna be 0 at here. And the full price is gonna be $150. And the question does not give us the second point, right? But we can find it out by using the setup here in the question. We know that this summer membership only lasts for 12 weeks. So after the 12 weeks, the membership is gonna finish, right? So in that being said, mathematically, after 12 weeks, you don't need to pay any money to join a club because that has been finished. So we can say that after 12 weeks, right? So if you join a club 12 weeks after the beginning of the summer, you're gonna pay nothing because the club is already finished. So we can say that the price is 0 at that point, mathematically speaking. So now we have these 2 points here, 0 and the 150. And another point that is 12 and 0, right? So, so that is the idea how we work this out. But now let's write these things formally in the space below here. Let me just move this here first. Copy and paste. Let me write this here. So question A, I have right now, I have to set this up. Now we let x represent the number of weeks since beginning of, summer. Okay. The now weekly cost of the membership, which is the slope it's gonna be m equal to y1 minus y2 divided by x1 minus x2. Remember the points that we have were 0 here. So it's going to be y1 150, right, minus 0 divided by 0 minus 12, which is going to be negative 12.5, right? So each week the price of the membership is going to depreciate by this amount of money, which can be thought of as the weekly cost. And now I have the total cost of the membership after X weeks, it's represented by f of x equal to, now I will use the Points-Law form, f of x minus this is y1 equal to m x minus x1, right? So it's f of x minus y1, that is, so assume that this is x1, y1. That's 150, right? Equal to m, that is negative 12.5, x minus x1, that's 0, okay? So I have right now f of x equal to negative 12.5x plus 150 as my final answer. That is the equation of the line. And some people may be wondering, what if I use the second point to plug in my Points-Law form instead of using x1, y1? You could, and we have demonstrated that in the last tutorial, that the answer is going to be the same no matter which point you use, as long as the point is on the line. Right, so now we have the equation of the line here. Very simple. Now let's take a look at question B. Compute the cost of a membership that is purchased 5 weeks after the start of the season. So that is a straightforward question. So after 5 weeks, that means x is equal to 5, right? So now x is equal to 5, right? We have that f5 equal to negative 12.5 times 5 plus 150. Okay, so that is negative 6. This one is 62.5 plus 150, which is equal to $87.5. Okay, so after 5 weeks, the price is gonna be depreciated, and it's only now $87.5. That is question B. Plug in, straightforward. Okay, so that is our question 2 here. So if you compare question 2 and question 1, they're exactly the same. So you basically what you do is you rephrase those informations and then convert them into mathematical symbols and notations. what we do in these two questions is that we just find 2 points, right? After finding these 2 points, we can use these 2 points to determine the line by using the slope formula and the point slope form of the equation. Okay. So now let's take a look at problem 3, and it should be the same as the previous 2 problems. Copy and paste it here. Now we have during the summer, a group of students builds this kayaks, right, in the converted garage, and the cost for the student are materials and the kayak and the rental of the garage. So it means that you not only need to pay for the materials, right? You also need to pay for the rental. So there are 2 parts of the cost here, the rental and the materials. For the materials, how much it costs you depends on how much kayak you're gonna build. If you want to build more, you're gonna pay more. But for the rental, it's a fixed cost. So it does not matter how much you actually build. Even though you're not building anything, you're doing nothing, you still need to have to pay for the rental of the garage. Right? So here, this sentence is very important, right? Materials for the kayaks and the rental of the garage, right? So keep this in mind. 2 separate parts of the cost. Now the material needed to build 1 kayak is $25. So the more you build, you're gonna pay more. If you want to build 1 more, you're gonna pay $25 more, right? For example, if you want to build 10 more kayaks, you're gonna pay $25 times 10 more money to this group. Okay, and the second condition here, that is the total cost for building 10 kayaks is $850. Okay, $850. That's the total cost. So if you're building 10 kayaks, then the cost, including the garage, the rental, and the materials, is totally $850. Okay. So we're gonna use this information to find out the equation of the line, right? Before doing that, let's set it up here. So so what we're working on here is the cost function c of x, right? And x is the number of kayaks that we are gonna build. Right? So what is c of x here? We need 2 points to figure out this function. Right? So the last piece of information has told us that if we want to build 10 kayaks, then the cost is $850, right? So this is the first point, right? So where is the second point? Go back to the previous condition. It says if you want to build 1 more kayak, you're gonna pay $25 more, right? So this condition tells you the slope or the marginal cost, right, of the kayak. Why is that the slope? Because x increases, y is also increases, right? So that is the ratio of the increment of the y and x, right? So build 1 more, pay $25 more. So it's the slope of this, the line here. So now we have already m, that is equal to 25, and x1, y1 is equal to this 10 and A50. So we can use the points law form to find out the equation of the line. So now we have y minus y1 equal to m x minus x1. Now y minus y1 plug in, or x1 y1, not x1 y2. A50 equal to m, that is 25, x minus 10. And then we can just simplify it. So I have y minus 50 equal to 25x minus 250, which implies that y is equal to 25x minus 250 plus A50. So I have y equal to 25x, right, plus this 600. Okay, so that is equation of the line. We will know this by c of x. That's the cost function. And now let's take a look at the cost of the rental of the garage for the summer. As I said, the rental of the garage is a fixed cost, so it does not matter how many kaya you actually build. Even though you're building 0 kayas, you still need to pay that price. So that being said, we can substitute x by 0 to just suppose that we are not doing anything in the summer and see how much we need to pay. So that's the fixed cost. Apple Pencil is dying, so let it charge for a while. So I have B here. X equals 0. We have C0 equal to 25 times 0 equal to 600. That is the cost of rental. Okay, so very simple. Now, is that all? We have question C, right? So question C here. Find the student's profit function. So speaking of profit function, P of x, we need the formula profit, it's equal to the revenue minus the cost. So we're gonna figure out the revenue function first, right? What is the revenue? So let's take a look at this condition. So each kaya is sold for $175. Okay, so we have built X kayas in the summer, and we're gonna sell all of them after for $175 each. So you're gonna multiply $175 by X. That is the total money you will get by selling the kayas, which is our revenue. So from here we know that the revenue R of X is equal to 175X. Right? And we're gonna plug this into this formula, 175X, right, minus my C of X, which is already given, or not given, computed here. So that is 25X plus 600, right? And then I simplify this, which gives me 150X minus 600, right? That is my profit function, P of X. Right? That is not very difficult. And now let's take a look at the next one. That is the how many kayaks must they sell in order to break even? What does that mean by break even? Break even means you're making zero profit. So that is when the revenue equal to the cost exactly. So you're not, losing any money or gaining any money. You just break even. So D here, we will let this profit function equal to 0, assuming that we're not making any money, right? The cost is equal to the revenue. So we have this profit function, that is 150 minus 600 equal to 0, which gives us that 150x equal to 600, right? And now divide both sides by 150. We have x equal to 4, right? So in order to break even, you have to at least build 4 kayaks, right? Therefore, the students need to sell at least 4 kayaks to break even. Okay, that is the question D. And now let's take a look at the last one. How many kayaks must they sell in order to make a profit of $450? Right. So if you want to make $450, you're gonna let the profit function be 450. And now try to find the x. That is the number of kayaks you have to build to reach that goal, right? So we have now our profit function just computed, that is 150, x minus 600. So now we have 150x minus 600 equal to 450, right? And we manipulate the stuff a little bit, so we have this equal to 1050 by moving the 600 to the other side. And now divide both sides by 150. So now we have divided by this, which is 7. Okay. So in order to make a profit of this, you have to build at least just 7 kayaks. Okay. Therefore, the students need to sell at least 7 kayaks to make a fit of $450. Okay, so that is the entire question. Question 3. a little summary. So basically we are working on finding the equation of the line first, and after we got this line, we plug this cost function into the business model, that is the revenue profit cost formula, P of x equal to R of x minus C of x, right? And that is the expression of the profit function. After we obtain the profit function, we set it to 0 to find out the break-even point. And in the last question, we set it to our goal, $450, to find out the number of kayaks we have to build in order to reach that goal. So just a little bit more stuff to do than the previous two questions, right? But basically the idea is the same, right? If you compare this to the previous two questions, instead of finding 2 points, you don't now even need to find 2 points because the slope here is already given, right? So there's no, we don't have to bother to find the slope, right? Like the previous case, it's already given here. Per kayak is $25, the marginal cost. So that is the difference between question 3 and the previous question. Now let's take a look at the the last question. Find the domain of the following functions. So that is a little bit different than the previous 3 questions. Okay, so let me remind you what a function is. A function is just like a machine, right? For example, say f of x. So it needs an input, and its formula will give you the output according to what you input here. So you always input a thing and output a thing, right? You input x here, right? The output here is f of x, which is this expression here. So if you want to know the function at the evaluated at 1, you're gonna plug in 1 here, and on the right side of the equation, you will see the output. However, it's not every input is valid. There is some number that you can't input in the function, right? So that is the concept domain comes. The domain is the collection of all valid input. Okay, and for example, when you have, you know, the rational function, right, like a fraction, then the denominator is not allowed to be 0. So if you input something and you ended up getting 0 in your denominator, that means that input is invalid. Okay, so we need to eliminate those things to make the our expression reasonable. So how do we work out the domain? So it depends on the type of function that we're working on. For the first expression here, a, I have f of x equal to a rational function. So for a rational function, we know that the denominator is not allowed to be 0. Except for that, everything is allowed. So we're gonna, for question A here, we're gonna let x plus 2, which is the denominator, equal to 0, and see what kind of value is invalid. So we have x equal to -2, which means x equal to 2 is an invalid value. For the domain, we're gonna take the rest of the numbers by just excluding this invalid value, x equal to -2, right? So that is domain is equal to x, right? Belongs to R, where x is not equal to -2. Or you can write this in the interval notation, right? That is from -infinity to, -2. This is the open bracket, right? Means that we are not including -2 into the interval. And union, right? And open bracket again. And we're going to take from -infinity at -2 to the positive infinity. So it's just everything except for -2. So that is the domain of question A. Now let's move on to question B here. Question B, we have GU equal to 2U minus 4 to the 3 divided by 2. So let's just recover this expression to see what it is by putting a fraction in the exponent. So if you have a fraction in your exponent, then the numerator is actually the power, and the denominator is gonna be the number of the roots that you need to take. So it's gonna be the square root and the cube of this 2u minus 4, right? So this is recover to 2u minus 4, take the square root, and then to the 3. That is how we recover this. Or you can just switch the square root and the cube to write this as 2u minus 4 to the 3 square root. So these two expressions are actually the same thing. They're not different from each other. So now how can we find the domain of this function? See, now we have something called the square root. When we have the square root, we have to guarantee that the inside, or the what is underneath the square root, to be a non-negative value, right? So what we need is to make sure that the expression that is underneath the square root to be greater than or equal to 0. Otherwise, you're gonna get a invalid input. For example, square root of -2 it's not making any sense. You want to avoid those situations. Okay, so the punchline here is to let the thing that underneath your square root, which is 2u minus 4, to be greater than or equal to 0, and solve for the valid input. So solve for this inequality, we need to move 4 to the other side. So 2u is greater than 4 right now. And now we can divide both sides by 2, which says u is greater than 2. Right? So the domain of this function, it's everything greater than or equal to 2. Real numbers is greater than 2. Or you can write this in the interval notation. Now since 2 is now included in the interval, so I'm using the square bracket, means including, right, to the infinity. For infinity, we always use round bracket. So that is the answer for the question B here. We have 2 left. That is question C and question D. Now let's take a look at question C. It's a little bit difficult, more difficult than the previous 2. So right now we have 2 things to consider. Before we said that we need to pay attention to the square root as well as the fraction. Right. In the denominator, we are not allowed to have 0. And underneath the square root, we're not allowed to have negative numbers. So you're gonna take these things into consideration. So now we have 2 square roots and 1 denominator. So there are 3 things to consider in this case, right? So the first thing is that we need number 1, make sure the square root, this z squared minus 4, right, is inside square root to be greater than or equal to 0. And the second thing, we also need to make sure, besides that, right, the other thing that inside the square root, that is z minus 4, to be greater than or equal to 0. And the last thing, we need the denominator to be non-zero. So the denominator here is z minus 4. That can't be 0. So there are 3 conditions here to be satisfied in the same time. We have to guarantee all of these conditions are satisfied. Otherwise, we will not get a valid output. And those numbers that are making all these conditions satisfied in the same time will be the numbers that is inside the domain. So we're gonna find all of these numbers by solving these 3 inequalities separately, and we're gonna find the intersection of these 3 things. So let's start to work on it by solving the easiest one here. That is z minus 4. So this one tells you that z must be greater than or equal to 4, right? That is the very first thing that you have to guarantee. If you have something that less than 4, then it's not valid to input here, because that will make the square root having a negative number to take. And now let's consider the third condition here. That's relatively easier because it does not have the square. And this thing is not 0, right? So that means if square root of something is not equal to 0, it means the thing inside the square root is not 0. So this simply says that z minus 4 can be 0, right? Which says that z can be 4. So as long as z is not 4, this thing is not 0. Okay? So z is not 4, right? Z has to be greater than or equal to 4. If we combine these 2 things together, we have that z has to be strictly greater than 4. Okay? Strictly greater than 4. Now let's take a look at the first condition here. It says z minus 4 has to be greater than 0, which means if we move the z to the other side, then this is z squared greater than 4, right? We have to have z greater than 4 from condition 2 and 3. And now z squared greater than 4, we see that it's already guaranteed by this condition. If something is already greater than 4, that is a positive number, and then you take the square of this thing, it will just get even larger, right? So this makes sure this happens. So we don't actually need to solve the red inequality here, because by the information that z has to be greater than 4, then z squared greater than 4 has already, naturally, automatically satisfied. Right? For example, you have, right, 5 is greater than 4, right? And 5 squared is equal to 25. It will just get even larger than 4, right? So this condition is satisfied right now. And now, in conclusion, we have that the domain of this function, that is x belongs to the real numbers, where x is, or here z, I should say, z is greater than 4, right? And you can use the interval notation, that is from open bracket 4 to the positive infinity. Okay, so it's the solution of question C, which is a bit more complicated than the previous two questions. We have 3 things to consider in the same time. Now let's take a look at the last one here. ht equal to square root. What is underneath is the absolute value. So let me remind you what absolute value does here. Absolute value is a function which will just take the quantity of the input, and it always output a non-negative thing. For example, if you input 1 or 2 in the absolute value, it gives you the 2 as the output. If you input the -3 inside, and then it will just remove the negative sign and output the quantity of this stuff, which is 3, right? So it has the ability to turn every input into a non-negative stuff. If you input 0, then it's output 0, okay? So it's a very good thing here, because we also have a square root here. When we have something underneath the square root, we have to make sure the thing underneath the square root is non-negative. However, the absolute value here, it's already doing the job for you. You have t minus 3, right? It could be negative, could be positive, but the absolute value is doing the job to make this thing non-negative. It's always greater than or equal to 0 if you have absolute value. So we are safe to take the square root of this output, right? So this output is always valid, right? So we take the square root of this absolute value. It's always defined. That being said, we won't have any invalid input in this case. That's very fortunate. So if there is no invalid input, then the domain it's all the real numbers, right? Or you can write this as from negative infinity to positive infinity, because there is no bad guys here to be eliminated. Every number, whatever number, you can plug in. So that is our question D. The domain is all the real numbers. Okay, you can use this letter R or the interval from negative infinity to positive infinity. So we have finished question 4 here, and I think that's it.